Welcome back, everybody, to another episode of Energy Bites here with Rad Dad, me, John Calfan. Before we get into anything, I just want everybody to stop real quick, go give us a review. Hopefully it's 5 stars, but give us some feedback. Tell us what you like, what you don't like, what you want to hear. Also, please, subscribe and share with us so we can keep going and get some more guests and stuff. So here today again with my trusty co-host, Bobby Nealon.
How's it going?
How's it going, Bobby?
Doing well. Excited. We got Igor Kuvaev with ROGII.
ROGII.
Mm-hmm. No, this is fun for me because I think first time other than John, got a former coworker on the podcast. Igor and I used to work on the Eagleford development team and at ConocoPhillips. So excited to have him on and kind of hear his story, because all I knew was he went from Conoco and all of a sudden, boom, he's CTO of ROGII, and you definitely want to unpack that story and how he got here. So welcome.
Thank you. Thanks for inviting. Looking forward to this conversation.
Yeah, thanks for coming.
But again, I gave a little bit of intro, but definitely not enough. You want to just kind of tell us about yourself, your background, where you're from, how you got into oil and gas, and all the.
Yeah, absolutely. Yeah. So my background, I'm a geologist. So I graduated as a geologist. I've been working as a geophysicist / geologist my entire career. And pretty much my career can be split into two major parts. First one, working for ConocoPhillips in various different locations as a geologist, of course. And one of those locations was obviously United States, here in Texas. So as Bobby said, I was working on Eagle Ford play when it was just starting, doing a bunch of experiments there, drilling those first horizontal wells, checking what kind of production is there, and doing, a lot of interesting stuff. And then I, with my co-founder, we were working actually together in ConocoPhillips. So we quickly realized that there is an amazing opportunity for further geosteering improvement, because back then the technologies were not developed, let's put it this way. So we quit Conoco and founded our own software startup.
Awesome. Yeah. So let's kind of make it into that. I mean, you're talking about that the technology wasn't developed. I'm trying to think back. We had the operations geologists, right, at Conoco, and they had to be in the office, right, and they had to be on these, they call them the Linux blades, right?
Mm-hmm.
I mean, so kind of what was it like then, and then what opportunity did you see, and how did you kind of pivot? Was there new technology available that wasn't being utilized?
Before you answer that real quick, just for the more tech focused people that may not know as much about the energy space, just give a quick kind of overview background of what a geologist does at an operator.
And maybe get into what geosteering is.
Kind of go from geology, like what the geologists typically do, where they're involved, and then how that ties into geosteering specifically.
Yeah, absolutely. So I think speaking about geology, I will be specifically focusing on geology of unconventional plays, because this is what we do the most, right. And it's substantially different from what geologist is doing for conventional plays, right? And for those who are not generally familiar, unconventional is what is being developed in the United States the most, because all the conventional plays, like old school plays, they've been developed, so the oil has been produced, so we switched to unconventional development. And this is what we do. So as a geologist, basically what you do in unconventional space, you plan wells. So you identify where the wells are going to be drilled, and those wells are always horizontal, with very minor exceptions, but let's say, always horizontal wells. So you plan those wells, you plan where the well is going to be drilled, like on the map view, where you're going to be placed those wells, where those wells will be placed in the reservoir, because the reservoir is, fairly thick formation, from maybe, 50 feet to 1,000 feet. So you need to know specifically where the well is going to be drilled, where the well is going to be placed. And then as the well is being drilled, you as a geologist, so this is actually what we do the most, you as a geologist, you control how exactly the well is placed. So you are in a constant communication with drillers, direction drillers, drilling engineers, to make sure the well is actually being drilled where it needs to be drilled.
Yeah, no, I think that's a very good explanation. And I think a lot of people, like I said, just don't understand, right? it's to me one of the like engineering marvels that is so kind of hidden in the energy space is the fact that we can start with a whole whatever the conductor casing is, uh, 30, 20, 30 inches around at surface and end up 2 miles down and 3 miles away from that one spot with a pretty tight degree of error, so to speak. Um, you know, it's pretty fascanating. In
we
my
just take it for
opinion.
granted now.
We really do, right? Like, and drilling is not easy by any means, vertically, no less, turning out and going, horizontally and stuff. So I just wanted to highlight that because I don't think a lot of people really appreciate how you're landing a 5-inch drill bit within within a few feet of where your plan or design was.
Yeah,
and so
I mean, and ROGII is a great intersection of like that physical technology along with now just integrating with great software. So
yeah, and I think what is also important to understand that because we're dealing with subsurface, it's we're very limited with the amount of data we receive, right? Because radio signal doesn't work over there. There is no GPS. There are like literally nothing is available to us. The data transmission rate between our downhole tools, it's 1 bit per second, not 1 byte, 1 bit per second, right?
Wow.
So we literally need to make multi-million-dollar decisions based on absolute absence of information. We don't have much. We can talk about how it started, what's going on right now. But yeah, it's a super exciting field where you need to react quickly based on nothing.
Yep. Yeah. So I mean, maybe like just in general, not even like say from Conoco standpoint, but just like what did geosteering look like when you started, say, in the unconventionals, and then how's it progressed? And I mean, now you guys pretty much own most of the market share, as far as I understand. As far as geosteering in North America, a lot of it. I mean, like. So how has that technology kind of transformed over the last 10, 15 years? And just, what did you guys do that just accelerated it?
Yeah, absolutely. So we, I mean, back then before we started, the geosteering was quite an interesting science. And it wasn't actually even, I would say, formed or created as science. Everybody was doing their own thing.
Right.
If you go to a conventional play, the geosteering would be some, I would say, pretty much dependent, like field dependent. Each operator, even each oil field, would do their own thing, and it would not be necessarily, clear the way they do that. I started drilling my first horizontal wells back, in 2000, maybe before 2010, and it was always a very unclear procedure, and it was on conventional fields. Now, when I moved to United States, I saw the big and dramatic difference between pretty much United States and all other countries is amount of downhole tools United States operator use. It's literally nothing. It's gamma ray only, which is the simplest and cheapest downhole tool you can find. And what shocked me here is that those are like $10 million decisions. I mean, back then the drilling was expensive. Is made based on that cheapest downhole tool and Excel spreadsheet.
Right.
So that how it was. I mean, yes, back then we as geologists we had some software, but those software were not far away from just doing basic math calculus in Excel. And this is what totally shocked me, and my co-founder were like, no way. I mean, it must be a better way. It must be a better way to make it easier and reduce amount of errors. And bunch of errors were done because people were not taking into account all available data, not necessarily real-time data, but the data that was available to the geologist at the time of the drilling.
Right.
And those errors could not be made. I mean, we could do something. We could do much better. And so then we started the company. Our main idea, I would say, our first approach to geosteerers, to geologists, was, hey, we should be able to integrate all available data, and by doing that, drill better wells. And of course, switch you from Excel-based software to something that an average person can use and enjoy.
Yeah.
So those two components, maybe the second one more than the first one, was something that picked up, very, very quickly. I mean, very quickly we pretty much took over the market.
What additional data were y'all kind of adding? Is that just like pilot test well logs and kind of being able to interpolate between different actual data points or seismic, or is it kind of all of the above?
So as far as geoscience data, before you drill or when you drill, you actually have a bunch of data available. So those could be nearby pilot holes, and I would say 100% of unconventional plays, they happen somewhere next to the existing conventional field, so they're very heavily drilled. So actually, we do know a lot about geology already, right? So we have a lot of that information, and we have those pilot holes, we have structure maps, we have seismic data, we have nearby drilled horizontal wells. And the more we drill, the more information we get. So the more data we can integrate. So that was the first kind of idea that we brought to the market that was very well received. Now, going forward, we definitely should, and we already can integrate some real-time drilling data, right? Because we have much more drilling data in real time versus the downhole gamma ray data. Right. So that data can also be integrated. But the first, like the core, I would say the core thing that really transformed the industry, and I would even say moved Geosteering from like strange Excel spreadsheet into a real science, real job, was that massive geoscience data integration.
Yeah, and I think that's been one of the kind of lowest hanging fruits in the oil field across the operation. Is just we have all this data, right? But it's siloed. It's in different software. There hasn't been a lot of, at least until last 5-10 years, right? There hasn't been a lot of effort, it seems like, in the energy space to try and it's like we capture all this stuff, but then using it is much more difficult, and that's why, in my opinion, we've seen all this kind of energy tech boom over the last 10-15 years in the space, because there is all this opportunity, especially from, that's what I love about it, is you've got people that you were a geologist at an operator and you saw that, hey, we have all this stuff, but there's no solution to do it how it would make the most sense, and so you go and start your company, and now you guys are kind of the dominant player in the space. It's awesome. I love that.
And I would even add using it in real time. Yeah. It's another level of complexity, because technically, even before us, I mean, can you take a look at your structure map on seismic? Yes, you can. As soon as you are in the office, you can take a look at it. But the rig doesn't care. The rig, okay, some companies are out there, they, not in US, but I've seen those, like, oh yeah, let's stop the drilling for the night and figure it out in the morning. No, it's not.
Time
it's
is
not.
money.
I mean, rig to rig is what, 7 days right now, or 10 days.
Yeah.
You cannot do that, right? The rig has to drill, so you need to have access to all of that data in real time by yourself. You don't have a luxury of stopping by and scheduling a meeting with your geophysicist daytime.
Take a week, figure it out. Yeah. No, that's another big kind of logistical, like, to me, the oil field is so difficult because it is this giant logistics game, right? Everything costs money. Everything is tied to this ever-changing commodity price ultimately. And so, we could do these things much easier and potentially better if we had more time, but then you've got the cost perspective of that, right? And so it's always this delicate kind of balance of time versus money. But do y'all, let's get into kind of y'all's kind of tech stack and that sort of thing. Kind of, how is that? Because y'all are, I assume, cloud-based in some aspects, but do y'all also have hardware on site, like any kind of edge devices yet, or is that kind of more future? Kind of what's your current kind of stack look like without, you don't have to give who, or if you don't want to, but just what does that kind of look like?
So at the moment, a majority of things we're doing is software based. We have edge devices as well. I can talk about it a bit later, but it's a cloud based solution that is hosted on Amazon, and I would say 2/3, maybe 3/4 already of our North American customers, they're all on cloud. So they store all of their well data, all of their geoscience data on our cloud. In fact, at the moment, we've got roughly 1 million wells stored on our cloud.
Wow.
And I would say on average, 20,000 wells are being added every month by the operators. It's not we, it's the operators, it's their own secured cloud. So they store the data and they access this data either in real time or later on for analytical purposes, whatever they want to do with the data. Now, we, even though we're cloud-based, there is always, a front-end part, right? Because this is what, this is the most important to the users, what's your front end. And for the front end, we have a desktop application that is seamlessly connected to the cloud and allows users to basically manipulate the data on the cloud, which is our StarSteer, the Geosteering software. And we also have a bunch of web-based applications for monitoring. So those ones are typically used either just by Geologist. In fact, we have like iPhone, Android apps, so they can just quickly see what's going on the rig. Or they are used by direction drillers or even company men. So at the rig side, they can actually see, what's going on. Yeah. So this is actually the main, one of the main advantages of the cloud. It's kind of enabling these true real-time operations. This is something you cannot do without the cloud.
Yeah.
It has
single
to be,
source data too.
Yes,
right?
it has to be on the cloud. It has to be updated in real time. That's absolutely important for the modern drilling. We do have a piece for the data. So most of the cases we rely on the data transmission from the rig that is established by EDR or rig providers. But for some cases, I would say mostly for outside of United States cases, we do have our own edge device that we put on the rig that actually collects all the data on the rig and then transmits that data again to the cloud, so everybody can use it.
Is that all WitsML?
Yeah, that's WitsML. So, okay, the transmission part, WitsML is, as many things in our and actually many other industries, is kind of antiquated protocol, but
it's standard.
It's been there, and at least it's standardized.
It works. Okay, it works. Yeah. That's the most important. We, as far as the data transmission, we have our own super compressed protocol because this is the bottleneck, the data transmission part from the rig to the cloud, right? But once it gets to the cloud, yes, it's XML.
Okay.
How do y'all? Let me ask, because I know this is a ever evolving kind of question in the kind of field IoT space, but what are y'all mainly using for comms for those? Are y'all using satellite, cellular, or like Starlink? Have you messed with some of that stuff yet? When
we put our own edge device, we rely on existing internet connection that typically rig operator is doing. We did some experiments with or maybe some tests with things like Starlink. It's an interesting technology. The biggest problem of Starlink is that it has to be always at the same place. It's by contract. Okay. So it's not really very well suitable for the moving devices, right? Yeah. So I don't know if anybody is using it for like rig operations. Maybe they are. Maybe they have some special things.
I mean, we're using it in the field, but again, I think it's more static site,
right?
Or
even like.
But there's a lot of not even necessarily Starlink. There's a lot of low orbit satellite stuff that people are doing now too. But But again, it sounds like especially North America, you've got internet connection on most of the rigs that you can utilize. So.
It's always nice that someone else can bring it and you don't have to worry about it yourself.
And also generally most of the places these days, very remote places, everybody has internet. I mean, it's cheap. Satellite internet is cheap. So luckily the connection is not a big deal these days.
Yeah. Talk to us a little bit about kind of the architecture process and the thought process that y'all have gone through, because, so like I was saying earlier, my background on the frac side, we have a ton of data. None of it is standardized. So at least you'll have that going for you on the drilling side, but we also have the same problems, right? You've got a ton of data. You've got real-time operations. It's expensive. People back in the office want to be able to see the data, but you also want to try and leverage as much of that data, both real-time and existing, to make on-the-fly decisions. And so kind of how did y'all kind of approach that, because it's not an easy thing when you're dealing with, real-time data or connectivity intermittency, or the fact that it can just drop out. There's all those kind of nuances of the oil field that you have to think about. So kind of just take us through, high level, how y'all went about kind of approaching that, or looking at some of those problems.
So once we decided to switch, so initially we developed StarSteer as a desktop application. So that was the logical thing to do, because again, you switch from Excel to, you don't want to go from horses to spaceship right away. Right? You need some intermediary point. So we once we designed StarSteer, we started to think, okay, obviously, everybody understood that, for real-time operations, cloud is essential. What do we do about the cloud? And as far as typical real-time data, which would be your survey data, it's a trajectory of the wellbore. So this gives you the location of the bed, and real-time game error logs. So those two, let's call it objects, are fairly small in size. So as far as architecture, I wouldn't say it's not a big deal, but it was fairly easy to make it real-time, because it's small amount of data. It can be downloaded from any location with even very bad internet. And of course, we enabled compression, so it made that data really small. When it got really interesting is when we decided to add some additional geoscience data. And geoscientists, they like huge data. Not necessarily, it's huge in value sometimes, but definitely it's huge in time, in volume. So those would be structure maps and seismic data and nearby wells. So, sometimes, think of like Eagle Ford Permian. There are like 1,000 wells next to you, right? Yeah. And you open a project as a geologist, you would like to see like a few hundreds of them. You would like to see your seismic data, you would like to see your grids. That entire project could easily be, over a gigabyte in size. And we need to bring it to the user that is located somewhere in Permian Basin, right, with not very good internet, and it needs to be in real time and it needs to be fast. And the user, geologist doesn't want to hear about, hey, your internet is limited. It's now I'm the provider of the solution, so now it's my problem. Even though it's not my internet. So this is where we developed a lot of fairly sophisticated tools on data compression and on like buffering the data. So let's say you download the data once to your computer, and then you go to the field, and it checks whether the data has been modified, and if it hasn't been modified, it won't download the data anymore. Okay. So additionally, the hardest part for us was the 3D seismic, because believe it or not, some 3D seismic volumes could be as big as 200 gigabytes. Yeah. And that's onshore US. So this is where the wells are being drilled. And of course, again, the users, they would like to have the access to that data right away, and even with like almost no internet. So luckily there is a very good seismic compression technology available, which we haven't developed. It's a company named Blueware out of Norway initially. They developed it, and they made it open source, and we collaborated with them. Speaking about successful collaborations, right?
Hey, so did you have to pay a giant fee to be a part of a big group to collaborate with them, or was it just a native, hey, this makes a lot of sense and we should do this?
No, they just provided it to us, and it's an amazing technology. We built it into our solutions, and now, believe it or not, even 200 gigabyte seismic data, you can view it in real time, while being on site. So it's an amazing thing. Yeah. And it's one of those things, right? Innovation is making something easier, right? It was possible before, right? You could call your geophysicist and, hey, send me a screenshot. Sure. But the innovation is, hey, now I can slice through my data, located in the middle of nowhere, sorry to Permian guys, and have access to the data in real time, right?
Yeah. You can see it when you're on vacation on your Android app, right?
Yeah, exactly.
Or Apple. No, that's maybe, yeah. Because I was going to ask, like, how it started. It always start cloud native, or was that kind of the logical progression? So, yeah. So I mean, how did you guys arrive on? I mean, AWS was the main player at the time, and yeah, I'm assuming it's been a good decision. How? I mean, let's say even from when you started with AWS to now, have you guys had to re-architect, or have you kind of been able to carry on with the same kind of architect, using the same tools? I mean, obviously, like, Amazon RDS is different than it was 8 years ago. I mean, depending on the different tools you're using, have you guys had to kind of pivot, or has it just been changing as you've added new features?
We changed a lot, but the logic we had from the very beginning was that we shouldn't rely on one single cloud data provider.
Okay.
So, and it's a fundamentally different development from what I've seen a lot in the industry, is when you heavily rely on specific microservices provided only by one single cloud provider. Again, it's not something is better, something is worse, but for sure for us it takes much more development efforts because we are literally cloud agnostic. We can switch to Microsoft next day. But on the flip side, the good thing is we see that many operators outside of the United States, they prefer to have cloud internally. Again, we can debate whether it's good or bad. Sure. Probably it's bad, but that helps us a lot because being cloud neutral, we can go ahead and install our solution completely, within their system.
So if they have a private cloud, then you can go put it on theirs, and it just probably needs Linux VMs and whatever.
They have everything internally, and that internal part is not connected to outside internet at all. And there are a bunch of other requirements that you have to follow. And I don't want to speak for others, but I believe for those ones who build something, purely based on Azure or AWS, it's either impossible or will take years to convert.
To refactor.
Yeah. You basically have to build it from the scratch.
Yeah. So you guys have been, heavily focused on being the agnostic, so you can be portable and
yes. That was from day one.
No,
yes.
I mean, I think that's a fantastic kind of tidbit piece of knowledge that anybody that's out there in the tech space currently or looking to develop something, if you have any intention of, I'll turn to the camera and be dramatic about it, but if you have any intention of selling software, especially cloud-based software internationally, this will be a very big thing, right? Because a lot of people don't realize this, but a lot of the NOCs and national oil companies have like data residency policies, right? Where the data physically cannot reside on a server outside of the country even, right? And so you have to have options to be able to install your software on their on-prem private cloud, or you don't even get considered, right?
And that's extremely serious. I mean, you can be put in jail in those countries for trying to bring data outside of the country, and it has happened.
Yeah, no, I had a guy that I got my master's with who worked at Baker in mostly Latin America, and he told me one time he had to go. There was an offshore job, I think, in Brazil. He had to go out to the rig, pick up the laptop, come back on shore, drive the laptop to the office, hand the laptop over to the operator, and then like wait in the lobby for 4 hours. And then they came back and had completely erased the entire laptop. And here you go. Right. Like it's a very real thing, and so that's just, again, I want to bring that up because in my past experience when I was doing edge stuff, that was a much bigger thing that I didn't even consider that pretty much every national oil company kind of has in place. So that's really interesting that y'all built it completely agnostic. It's really smart, actually.
Yeah. I mean, and so one thing maybe to pivot in a different direction, I mean, that's about keeping the data secure, and that's extremely important, but you also have some other kind of integrations and kind of data sharing capabilities through your ROGII cloud and everything. So, I mean, because one thing I want to get into is you have a Python module where people can write Python within StarSteer, right? Is that correct? So, I mean, can you talk about that innovation, and then ultimately I'd like to kind of maybe get into the data sharing, because I know you can share with Snowflake and different people's clouds and Spotfire, which is a big deal for a lot of people. So, but maybe we want to start, because I always found that very interesting, and I think John and I always talked because I know there's for some crypto stuff where he could write in his own little language, in some of those crypto bots, but like say like geologists who know Python can come into your platform and write their own functions and do their visualizations custom within your platform as well, right?
That's actually a very good question, because initially when we developed, so yes, we have a bunch of interesting integrations, and we started with basically having Python within StarSteer, so a person can code. And when we started it, I thought it's pretty much feature for myself, so I can enjoy coding Python while on my long flights or whatever. But it picked up very well. So amazingly, geologists who are not coders by education, they picked it up. We see a lot of Python coding in different companies. In my previous operator where we work together, in many other companies, they sometimes even have dedicated group of people who code scripts under StarSteer, and it's always very interesting customizations, very interesting script. Mostly all related to the field of like data integration, maybe sometimes data cleaning, data analytics. Because think about those projects like thousands of wells, right?
Sure.
There's so much information you can get out of it if you just analyze this data as a whole, not like well by well basis.
Yeah.
Right. So then we, because we have our solution on the cloud, we developed what is called Python SDK. So this is also Python, but it allows any other companies to pull and push data from our cloud and to our cloud. And that was also very well adopted, but actually the group of people who are using it is slightly different. It's typically either like not geologists anymore, like true data analysts within operators, or different service companies that would like to say pull the data and make the data available to direction drillers, make data available for to completion engineers, to whoever needs geoscience and drilling data in real time. Because the beauty of our real-time cloud is that the data gets to our cloud first. So if they would like to get the data, and it's the easiest, or the easiest ways is just to go to our cloud, and it's always latest and greatest up to date with the interpretation available. So they can take either the raw data or the interpretation, and they can use for whatever they want to.
No, very cool. And so I'm assuming like that Python SDK would be kind of originally how people were able to do ETL, like pull data into their data warehouses or into their within their firewalls, whatever. But now is it I forget. I've seen some of your brochures, but you have like ROGII Cloud or the different ways of like sharing. Because each over you can share it to SQL Server, you can share it to Snowflake or BigQuery, whatever people are using. Is that through the Python SDK, or do you all actually have native connectors and or that stuff as well?
It's kind of through Python SDK, but it's developed internally. So basically, we have our internal development called Solo Connect, which is a small application that pulls the data out of our cloud and stores it into either SQL or Snowflake or whatever the database operator prefers. And the logic is Bobby, like you just described, is now you have it all in SQL in the way you prefer it to have, with specific data all cleaned, interpretations, raw data all together. So now we can put together our own dashboards, and of course, all operators they sort of compete with each other for the prize of the best dashboard available, and they all develop their own dashboards. Sometimes we provide them some templates. Okay, guys, this is what you can do, and we're constantly in communication with them. See, maybe you'd like this specific functionality, so we can add some more into those SQL tables, and you can pull more data, or you can make it more attractive to your current operations, more useful, because all dashboards are beautiful, but the question is which of those are useful, right?
Exactly. Just like the whole models are wrong, but some are useful. But so I think looking at all those, whether it's like the original Python model, Python SDK, or you're obviously iterating on like dashboards, or how people want to see the data in SQL, how does that help kind of shorten feedback loops for your software development? Or have you gotten a lot of like ideas for the the actual platform from seeing what people are using the data outside of it. And
Absolutely. We strongly believe in constant communication with the users, this is probably where users' feedback is so much more valuable than like managers' feedback, right?
Sure.
Because the typical question that we try to ask users, please don't talk about greatness of StarSteer, and if you want to, please go ahead. But the most important is please talk about your pain. Tell us what you dislike. Tell us what concerns you, or maybe about some things that you would like to do that you cannot do at the moment, and show me as a separate question to what you just said. Show me, maybe your dashboards or whatever you can show me, so I can better understand your workflow and your challenges. Because when we see all of those different approaches, and companies are still different. I mean, there is general workflow that everybody is doing, but as far as like truly innovative thing,
right,
everybody is doing their own thing. So show me what you're doing, and when you see all of those things all over the world, you can better understand what users actually want, right? How you can make their life easier.
You have to see a certain pattern showing up multiple times.
Right.
All right, this is something we need to prioritize because there's definitely a demand for it.
And I was going to ask you what, because we were talking about databases with the connector. What are you seeing more adoption of like Snowflake from MySQL, or is there kind of is SQL still the kind of common database that people are dumping their data into?
SQL is by far the most common, but definitely users they tend to store more and more data. I mean, we all see that trend. It's more and more data, especially going into the real-time drilling data. I mean, we're gigabytes per well of data, and now you want to do fast analytics based on like hundreds of those wells, right? So we're talking about huge amount of data and ability to quickly process that huge amount of data. So I think this is we're going into even like NoSQL type of space, real-time databases, and it's something where the technology is being very quickly developed over the last few years, because just SQL cannot do it anymore, right? So Snowflake is a good one. I think many companies are switching to Snowflake. There are others, NoSQL database, I would say, that are in a stage of experiment right now. But I guess the good thing about us is, even though we have a lot of data, we don't have as much data as many other industries, like automotive or just manufacturing or IoT. So there are databases that built for those guys. We don't need to reinvent the wheel. We can just steal ideas from them.
No, absolutely.
Yeah, and I guess those things too, like that's what you're seeing on the operator side. But I mean, and as much as you're willing to talk like about your internal stack, I mean, I was curious. I mean, you're doing a lot with the Python SDK, and I think that's probably more because that's what people are, outside, especially engineers and geologists are more familiar with Python. Say that, because half the other companies have C# SDKs, and you need an actual developer to do that. Whereas maybe the Python, you can, engineers and geologists can actually tap into that as well. But I mean, what are you guys using internally, and like, are you using any, like you said? Are there any like time series databases that you're using that have been, really helpful? I mean, just because I'm sure some people are trying to like, how do I tackle these kind of these kind of issues?
I was going to follow up. Part 2 to that question is, can you talk about, again, at as much length or not as you want, but about how y'all do handle, like, just different. It could just be strategic. You don't even have to get into details, but strategically how you go about, being able to handle hundreds of gigs of data with the real-time component and needing action and models. Like, y'all using serverless where you get spun up and spun down, kind of piggybacking off of the database piece, but I'm curious on kind of how y'all, your thoughts on that.
So just to quickly start about Python. Python is a great language. I'm not a coder by education, so the only language I can code is Python because it's simple and there are so many. I mean, ChatGPT can code on Python, and pretty much over the last maybe when it was released like 6 months ago, ChatGPT is coding for me. So it's amazing. It's great, but Python is pretty much useless for true software development, right? Because when it comes to heavy data or like nice and actually what I think any software company spends 90% of its time is interface and backend. I would say maybe even interface is more than a backend. So you need something fast, something reactive, something super easy to use. I mean, Python is useless there.
Yeah.
Python is great for prototyping. So as far as coding, most of our front end is done on C++, which is by far the fastest and the most advanced programming language.
Okay, and so that's for the desktop application?
That's for the desktop application, yes. For web applications, of course, we use JavaScript. I don't think there are any alternatives there. Backend, we use Java. And we have a lot of other, maybe smaller. It's probably hard to find a programming language that we do not use right now.
Enough for
we use a lot of them, some really old ones, but for specific purposes, like maybe some heavy math calculations, we use one language, and something else we use a different language. Now, going into the database space, as I said, there are many databases appear like literally every day, and
vector databases. And
we tend to generally look at what's going on. Specifically, a couple of years ago, we started developing applications for real-time drilling data analysis. And we investigated lots of different databases available. And again, the key is not to have like every hour update or every 30-minute update. We want it to be real-time, and analytics needs to be available real-time. And we use a database called ClickHouse.
Okay.
It's fairly new, but based on pretty much all performance. And it was developed, of course, not for oil and gas, right? It was developed for IoT. Based on all the performance tests that we've seen, and we repeated some of them, it's by far the fastest one.
Yeah, I've heard it's super fast. It's almost like comparable to, say, to Snowflake, but you can run it anywhere.
Yes. And we tried it on real drilling data. Of course, for that type of database, drilling data is almost nothing. It's it's a small data set for them, and it's amazingly good. Yeah. So this is really cool. This is our for now, right? For now, it's our database of choice.
No, I mean, but I'm imagining you're probably architecting that API layer, or whatever, like to be somewhat agnostic to the the database. So if you need to rip out one database and plop in something better, you can kind of do that as well.
Yeah. And again, speaking about deployment outside of AWS and major cloud providers, very commonly there is a request from operators that they would like everything to be deployed on a specific database.
Okay.
Because they like it. I mean, it's usually not a logical reason for that, but so for those, we're basically ready for those types of scenarios. This is very important for us.
Yeah. I mean, just one thing, just piquing my interest. I imagine, have you all looked at like DuckDB recently, like very much or recently? I mean, I've just heard very good things. It's almost like SQLite, but for analytics, and makes for some processing. So just curious if you've investigated it yet or not.
I don't think so, but maybe something for us to take a look at.
Yeah, no, it's interesting because you can do it through Python or R too, but it's like basically like what SQLite is, but it's columnar, and you can chew through data super fast. Apparently. So I'm just curious if that's something you guys had evaluated yet, but kind of my chance to nerd out. So
tell me, because we're gonna be wrapping up here in a second. I've got one. Normally, we kind of ask before we get into this last part. What's one thing you're excited about as far as the energy space moving forward, or what's some advice you would give? I'm very curious on how, obviously, with my soiree into edge computing stuff. How do you see edge kind of? Where do you see edge today, and how do you see it kind of in the future as far as its potential impact on oil field operations specifically? Because to me, that's where it has the most potential opportunity. Also, the hardest thing to probably implement as well.
I think it's a very good question, and maybe a fairly long discussion on edge computer for oil and gas. Long story short, I think I can understand edge for edge devices for manufacturing facility, or maybe for a vessel that transports LNG and has no or very poor internet connection. I think for the modern, and we all understand it's very expensive technology that is hard to deploy and takes a lot of time to deploy. I think for the modern drilling, with internet connection speeds that are getting better and better, right? And we're drilling in heavily developed areas. So typically we're drilling somewhere where internet is cheap and good. Not that edge is not useful, but I think that component of calculation at the rig in order to reduce amount of the data that we're sending back to the office, I think it may not be that critical and that big. It will be some calculations and maybe data compression on the rig side, but then the data will be sent to the cloud where the calculation is taking place, where we can integrate all possible data or nearby wells or whatever we have, and the final outcome sent back to the rig. So I think this is where it's all going.
Yeah.
As far as automation, drilling optimization, geosteering automation, this
kind of
is
a hybrid setup almost.
Yes, I don't think it will be like those serious calculation taking place at the rigs.
Yeah. I mean, that's interesting. I mean, perspective, because I know there's other people making the contention now there is enough horsepower to run, because now you can basically run clusters. Mm-hmm. You can have a cluster of IoT devices that are almost like your own mini cloud on location. So I know some people are thinking about it totally differently, but I mean, I tend to lean your way. But it's a matter of that's where I think it's because I think what we've heard say on the completion side, it's like where maybe you don't have a strong internet connection. If you lose connection to the cloud, then basically those people are in the dark for, however long that connection's out. So I'm curious if you guys ever run into that very much, but it's just interesting to hear. But I mean, it sounds like you guys have a pretty strong connection most of the time. And I think it's best to offload some of that to the cloud and then send it back, and you can send it to everyone else internationally or nationally much more easily from the cloud as well. So it's one of those things to me that the benefits of it on paper sound really good. The execution of it is significantly harder, especially because it's still, I would call it fairly new, even though it's just on-prem again, but it's distributed on-prem in this instance, which makes it a lot more interesting. But yeah, no, it's I don't know, right? Like the goal of all of this would be the rig steers itself, right? You dump all the data into the edge device. It's got all your surrounding wells, all the seismic, all that stuff. And it's just running its model and control, integrated directly with the PLCs and the control systems and the rig, and it just does itself. I think that's it's going to take us a long time to get to that spot, purely just from the risk perspective, right? Like, we talk about risk a lot on here. Just so.
It's one of those things though, because it's a double-edged sword, right? Like if you're trying to automate, you can't have it solely in the cloud, because if you lose that connectivity and the rig,
it just stops,
right? But then you can't also rely. Like it's a tricky.
You need that intervention,
right? So, you also have to have reliability of that. This model is going to work all of the time without a human being in front of it. So it's an interesting spot. I was just curious, like I said, because there is a lot of the promise of one of the big promises over the last 5 years with machine learning, right, is that it will use machine learning to make our operations better, to automate things, all this stuff. And then of course with all new technology, they go through that hype cycle of overpromise, underdeliver, and then everyone's really down on it. And now we're kind of coming back up to realistic expectations. And
my favorite analogy here is Tesla autopilot.
Yep.
Think about Tesla, 4,000 data engineers and unlimited amount of data, and by far data quality much, much better than we have from downhole tools.
Yeah.
And still, if you ever driven Tesla autopilot, it's not great.
No.
It cannot drive by itself.
Yeah.
And we will not be able to drive by itself probably in the next 5 years, 10 years for sure.
Yeah, I just want it when I'm commuting to and from the office, when I'm sitting in traffic, so I can just mess on my phone and not have to worry about running into the person in front of me.
Yeah.
Like, those things are really nice.
Well, that, and just when it literally gets a mind of its own. I was reading last night, there was a story about the U.S. Air Force did the simulations with an AI-enabled like drone pilot thing. But it had a human telling it whether it could kill or not kill, but like it was given its objective was to kill these things. But what it started to realize was that the human would tell it not to, and it tried to attack the human or the base that was, because it interpreted that as a threat, because this was stopping me from doing my job,
from completing the mission. Yeah. No, that's I think the big thing people don't realize about any AI model is it's the 0.1% of outliers that
you can't comprehend or conceive.
that take years, if not decades. Like one of the Tesla stories I remember, and Tesla, like they've done a ton around edge. They have their own in-house developed with, I think, NVIDIA edge device or edge computer on every single vehicle, right? Like Ford and some of these guys aren't doing
it. It is
that.
cloud-based edge device,
right?
The Tesla car.
That's the beauty of that idea too, right? Is like federated learning potentially of having all these devices learning locally, sending up and accelerating the learning of the mother model or whatever. But like there was one, it ran into like I think it was just like a white box truck because and it showed the Tesla AI computer vision video of it, and it didn't recognize that it was a truck because it was just plain, the whole thing was white.
Okay.
Right.
Okay.
And so just little shit like that, there's so many of those instances that if you don't train the model, it doesn't know. So,
and you take for granted what your brain, just calculating just at every instant, you just don't realize all the inputs that are coming in until it's not there. And you're like, oh wait, that's weird.
Until it runs into another car. Right. I've got a couple quick, we kind of do at the end, we call it like lightning round, just quick answers or quick questions and answers. And Bobby will ask you some, but I'll ask you some as well. What kind of software, app, service have you used recently that you're excited about that you've recently found that people may not know about or even may know about, but you're just really like the new tool or whatever?
Specifically for oil and gas, I think it's hard to say.
It doesn't have to be oil and gas.
It could be just tech or right?
I mean specifically about tech. I'm super excited about Tesla applications. I hate how it drives, but and I won't have one because of that. But as far as the software development, what they do, the true agile approach, I was shocked. I haven't driven Tesla for a while, but recently I took it, and I'm just the way they reinvented the wheel by doing software application for a true hardware device. That's amazing.
Yeah. That's again another underrated piece of tech, right? What's one of your favorite books, either in general or about technology?
I like to read just books about business experience, sometimes historical books, but mainly about business and how I probably cannot say a specific one, but just people who build something big and sharing what kind of things they went through. However, we always need to take into account that it's always a survivor bias, right?
Yeah, for sure.
It's whoever. Sure. What I really like to read, I couldn't find that book. If maybe someone can recommend, I would be so happy to read it. Is someone writing a book about his or her failures? Sure. What went wrong and why it went wrong.
Yeah.
So for some reason, people don't like to share that experience, and this is the most valuable experience.
Absolutely.
Yeah, I'm trying to think. I mean, I've read a good bit of business book. I mean, it's still kind of more of a success story because it's Andreessen Horowitz, but The Hard Thing About Hard Things by Ben Horowitz. I think he talks about some of the ups and downs, at least over the time of kind of standing that up. But yeah, to your point, most people aren't going to write the postmortem, right?
Yeah.
That's why I really, respect Equinor when they did their postmortem with Price Waterhouse, because it was here's everything we did wrong on U.S. shale. Here was the price text we used, and here was all of our, because again, people can learn a lot from that.
Yes, but it's very painful, and it's you have to have a very specific culture to be able to publish that. Yes.
Yeah, absolutely. So I mean, what's your favorite cloud to work with?
I mean, probably AWS.
Yeah.
I wouldn't be very, very specific here. It's good. They listen to. They listen to you. They do improvements. We see those improvements are happening. We have some services we were unhappy with. We talked to them. They accepted it. They didn't disregard the fact that it doesn't work very well. So they modified it, and now it works better. So yeah, I like working with them. Even though it's a big company, they listen to you.
Nice. Mm-hmm. What's your favorite open source tool or service? Maybe other than Blueware, I guess you guys have used that.
Blueware is not open source, but it's free of charge to use. So for those who want to use data compression, I would say generally open source. Everything that is coded on Python. A bunch of those like GitHub Python repositories. Sometimes you just randomly find something that was built
solves your problem
for geology. And
do you have one that comes to mind that you might share, a library or a repo?
I like. So there is one for anti-collision calculations called WellEng.
Okay.
Well engineering, shortened. I think it's just one. I don't know him in person, but like one drilling engineer, in his free time, he develops it and he keeps updating it. I just like it very much. There are other libraries. There is one for us. I actually use it a lot for seismic data that was developed by Equinor. Forgot the name, but I think it's only one seismic library within Python. There is one for well log visualization called Welly. I also use it on Python. Probably those are like the most common ones for geoscience.
No, that's
those are the kind of things we want to share with
That's exactly what we want to get out into the world. I mean, it's so crazy to me with Python, right? Because there's so many libraries for so many different things, and then you start getting into the oil and gas stuff, and it's like there's one.
Yeah.
Well, thank God there's one, right?
Yeah.
There might not be any, right?
Many thanks to those guys. Yeah.
I would say like Python's the second best language for anything, basically.
Yeah.
No, I love that about the energy community too. We solve problems, and if we identify that there's not something there, someone at some point will probably come and find a way to build it. But I'm going to ask what's something you would, or a piece of advice or something you would tell somebody that's looking at kind of starting their own energy tech company that you've learned over the years that you would give to them? I know that's a loaded question because there's a lot of answers to that.
That's not the short answer.
What's kind of one big thing that you would advise, especially around this software side?
I would say the biggest advice is if you think that what you're building is absolutely amazing and exciting technology, make sure it's not only you who thinks so, but you actually challenged your technology with users. And yes, it doesn't have to be 100% of approval rate from your future user group, but maybe just interview 10 separate people and make sure that out of 10 at least 2 love it. Those would be your first innovators. If nobody likes it out of 10, probably it won't fly.
Yeah, no, that's to me that's one of the hardest things of development in general is you never have like 100% consensus on pretty much anything from your user base, right? And so it's very hard to like prioritize and figure out, or like you might have an 80% consensus, but then there's the other 20% that get mad about it. And it's just like, well, what do you want me to do?
Yeah, it's never gonna be good enough, but you definitely have to, like you said, challenge your thesis. Or I mean, again, or you can spend too much time working on your baby and then you put it on the market and everyone tells you your baby's ugly. Like you said, you just got to kind of shorten those feedback loops and again, maybe get it to 10 people that you trust at least. Will break it to you nicely, but you got to do that early. So
exactly.
Then pivot the direction.
That's a very typical problem with any startups. You solve your own personal problem that you would like to solve, but maybe it's only yours problem. Nobody else cares about it, right? So talk to people, make sure, they have the same problem at least.
Yeah, 100%.
That's good advice. Yeah, because a lot of people go and build and then try and find product market fit. Like, oh, that's not there.
Yeah.
And it's okay. I mean, generally saying, it's okay that people are not, most of it's only 5-10% of innovators, like true innovators out there. It's okay that your technology will be liked by minority of the people initially. That's totally fine. It will be picked up later on, but that minority has to exist, right?
Yeah. Oh, talking crossing the chasm here. I like it. That's one of my favorite. That's my answer to that book question is crossing the chasm. That's a great one. You got one more, Bobby?
Let's finish. All right, that's kind of easier one. What's your favorite video or board game?
I played maybe too much. Probably boring answer. I played too much Monopoly with my son. That's we it's I think it's a good game.
I was going to say it's not a boring answer. It's very strategic.
It sounds simple, but there is a strategy behind it, and I figured it out much later than he figured it out.
Yeah.
So,
and how old's your son now?
10.
10. Okay,
That's awesome. Thank you for coming. I appreciate it.
Thanks for having me.
Great having you on.
Yeah, great conversation.
Where can people find you and learn more about ROGII?
Definitely website ROGII.com, which is easy to remember. It's 2 co-founders named flipped. So we have our office like five. That's our typical question. Can you guess what's the name? But we have our office here in Houston. 5 minutes drive from here, and pretty much any place where people drill for oil, we have office or representatives. So we would be happy to talk to you to hear. Yeah, tell us about the greatness of StarSteer, of course, but please tell us about your pain first. Tell us what bothers you. We would be happy to solve it.
Awesome. Well, thank you so much. Thanks, everybody.
Yep, thank you.
We'll wrap it up. Again, go and give us some reviews. Subscribe where you get your podcasts. We'll see y'all next time.